morning actually. Good morning everyone. Okay, now let's continue our hour 4. So hour 4 will be we discuss on Alamak. Sekejap. Mana saya nak buat stop sharing, stop presenting, present your entire screen. Share. Mana saya nak next lah. Ni tak boleh next kan? Okay dah.
Dia kena pergi sini. Ni. Panah tolak ke sini. Tu. Pergi situ. Dia kata ada dua screen.
So yang sekejap ah. So macam nak pastikan dia orang ni nampak? Yang online tu
Dia
nampak?
nampak ni. Dia akan nampak ni.
Okay.
Bukan ni, tengok ni.
Okay. Ni.
So dia nampak dah.
Ya. Okay. Mana dah? Ni.
Tak, satu lagi. Perempuan tadi. Ya.
Okay. Okay, okay, tengok nombor 18. Describe the properties of liquid in terms of intermolecular forces, molecule arrangement and the molecular motion. So kita nak explain liquid in terms of shape, volume, surface tension and its viscosity. Okay, for shape, liquid will take the shape of the container. Kenapa dia boleh ikut container dia tu? Sebab liquid ada intermolecular forces but not strong enough. Kalau strong enough dia jadi macam solid, dia duduk rapat-rapat. Tapi kalau dia tak ada intermolecular forces langsung antara gas, antara particles tu, dia jadi macam gas. So liquid ni sometimes dia ada bahagian yang dia tiada. So dia boleh flow. Okay. So since dia boleh flow, dia akan ikut bentuk bekas dia. So kita akan bagi tahu it will take the shape of the container because of their intermolecular forces attraction are not strong enough. Okay. So if not strong enough, we can put the molecule at fixed position. Okay, number 2, for liquid, it has volume which retains its volume. Okay, maksudnya fixed volume of liquid. Okay, ini disebabkan kaitkan dia dengan intermolecular forces. The intermolecular forces are strong enough to hold the molecule close together. Okay, so next for surface tension, liquid ada surface tension. So dia punya surface tension is better than solid and gas. Gas tak ada surface tension. Okay, so apa yang menyebabkan intermolecular forces ni membentuk surface tension? Intermolecular forces pull the molecule towards another molecule in all direction. Pull inward. Maksudnya dekat atas tak ada. Okay, tapi inner dia ada. Okay, so dia macam mana dia form intermolecular forces tu? So dia inward and sideways to the neighboring molecule. Okay. Yang dekat rumah dengar ke?
Dengar, madam.
Okay. Nampak kan? Next, untuk viscosity is the tendency of liquid to resist flow. As the attractive forces stronger, the resistance flow harder. So untuk liquid, dia boleh flow. Tapi untuk yang viscosity yang tinggi is because of the stronger attractive forces. So kalau IMF dia kuat, dia boleh flow dengan mudah tak? Strong intermolecular forces. Maksudnya dia pegang antara molecule and another molecule tu stronger, right? So very hard to flow. So viscosity dia tinggi. Okay, kelikatan dia tinggi. Next is explain the following processes based on kinetic molecular theory. So bila kita nak explain vaporization and condensation, so kita kena kaitkan vaporization dan condensation based on their kinetic molecular theory. First, you kena bagi tahu vaporization ni what is the phase changes. So it's from liquid to vapor. So apa yang dia buat? Yang daripada liquid to vapor, is it release energy or absorb energy? Liquid to vapor. Jadi kita nak tahu dia absorb ataupun release energy, tengok susunan liquid tu. Liquid duduk rapat-rapat. Now vapor duduk jauh-jauh kan. So intermolecular forces tu dia dah berjaya overcome dan duduk jauh-jauh kan. So energy is released or absorbed? Okay. Kalau duduk rapat-rapat ada intermolecular forces. Now dia buat apa untuk overcome intermolecular forces tu? They absorb energy. So during the process of formation liquid to gas, energy is absorbed. Okay, number one, you state the phase changes from liquid to gas. Yang kedua, energy is absorbed. When energy is absorbed, what happened to the molecule? Molecule possess higher kinetic energy. Okay, yang kat rumah tu you perlahankanlah volume you. Memang aku kalau kat kelas aku akan cakap kuat-kuat. Okay. Apa dah tadi? Okay, absorb energy. So, molecule possess higher kinetic energy. And then dia buat apa dengan energy tu? Overcome the intermolecular forces. When it can overcome the intermolecular forces, it's no longer close to each other, but they can escape to form a vapor. That's it. So jangan takut untuk explain. Okay, I repeat, you need to state the process, the phase changes. Number two, you need to state whether energy is absorbed or energy released. And then, apa yang digunakan untuk energy tu? Energy tu guna untuk apa? Untuk break bond ke? Untuk form bond ke? Okay, untuk overcome intermolecular forces. Right. Okay, lepas tu, so dia dah berubah phase dia, it can move freely. Since no longer intermolecular forces, now dia dah jadi gas. Boleh faham? Okay, good. So same goes to condensation. So condensation, terbalik daripada vaporization, it's from the gas, phase changes from the gas to the liquid phase. Okay, state the phase, right? Now, energy is absorbed or energy is released. Okay, daripada partikel duduk jauh-jauh, tak ada intermolecular forces. Now, back to liquid, ada intermolecular forces. The bond form back. Energy is released. Ingat, tenaga tu sentiasa diperlukan untuk overcome intermolecular forces so that you can duduk jauh-jauh. Sekarang, kita dah duduk dekat, means kita dah release energy. So the energy is released, gas particles has higher kinetic energy or low kinetic energy? Low kinetic energy. So since molecule has low kinetic energy, can they overcome the intermolecular forces? No, right? So dia tak boleh lagi overcome intermolecular forces, form back the intermolecular forces and form back the liquid. Okay? Okay, macam itulah. Bagi tahu phase changes, energy release or absorb, and then pertukaran phase itu macam mana? Boleh overcome ataupun tidak. Sekejap nak minum. Okay, define the term vapor pressure. Okay, vapor pressure, vapor over its liquid in a closed container. You imagine satu bekas yang tertutup, ada liquid, atas dia ada gas. That is the vapor pressure. Okay? So atas ni vapor pressure lah. Right. While boiling point is refer to the temperature. Temperature bila? Bila vapor pressure, okay, vapor pressure ni has same pressure as the external pressure. Okay, is the temperature. Ambil temperature bila the vapor pressure is equal to the external pressure. Okay. So, boiling point ni dia boleh berbeza-beza lah. Boiling point water, kita boil dekat sini, pressure dekat sini lain. Bila kita boil dekat Gunung Everest, the boiling point akan lain. Okay. Okay, next, the boiling point of a liquid increase with the increase in the strength of intermolecular forces. Okay, then we need to explain the statement. Why the boiling point is increased bila strength of intermolecular force increase. So kita kena faham proses boiling point. Boiling point adalah daripada liquid yang bertukar menjadi gas, kan? Okay, apa yang kita perlukan semasa kita nak transform daripada liquid to gas? We release energy or we absorb energy? Boil, ingat proses boil. Letak cerek air tu dekat rumah kan. Ke kat rumah ada kowe tak tahu boil ke tak. We absorb the energy. Bukan we absorb. The water absorb the energy. When the water absorb energy, the energy is used to overcome the intermolecular forces. So, kalau strong intermolecular forces, more energy required, right, to overcome the intermolecular forces. So, boiling point akan tinggi. Okay, so back here, dia kata, so macam mana kita nak kaitkan intermolecular forces dengan strength of intermolecular forces dengan boiling point. Okay, energy is absorbed to overcome the intermolecular forces. If the intermolecular forces kuat, means more energy required. Then the boiling point will be higher. Okay. Contoh, water. Water is the highest boiling point, right? 100. Sebab apa? Sebab intermolecular forces di dalam water adalah hydrogen bond. So dia bentuk banyak hydrogen bond. Dahlah hydrogen bond tu kuat, hydrogen bond tu pula banyak untuk water je. Between water molecule and another water molecule yang lain. So more energy required. That's why dia punya boiling point dia tinggi. Okay. So, saya tak nak isalin ni ya, sebab kalau isalin nanti idea tu tak develop. Okay, I want you to write in your own words. Okay, now. So arrange the liquid in increasing order of vapor pressure. So sekarang kita tengok. Kalau dia bagi boiling point, tapi kita kena susun ikut vapor pressure. Okay. We have ethanol, which is the lowest boiling point, and then followed by methanol, 65, and then the highest boiling point is the ethanol. Look at the intermolecular forces. Okay. Right. Untuk ethanol, it is non-polar molecule. Non-polar molecule, kita dah belajar IMF sebelum ni, it is weak van der Waals forces. Okay. For methanol and ethanol, it is hydrogen bond. So hydrogen bond lebih kuat daripada ethanol. Lepas tu, okay, kemudian kita ada ethanol dan methanol. Both have hydrogen bond, but methanol has low molecular size. So orang yang kecil, orang yang okay, ni molar mass dia 78, lagi besar kan. So lagi besar seseorang tu, macam orang tu obes lah kan, banyak lemak. So lagi banyak tenaga yang perlu kan untuk buang lemak dia kan. Dia perlu burn lagi banyak. Okay, macam itulah contohnya. So disebabkan molar mass dia paling tinggi, hydrogen bond dia juga paling kuat dan boiling point dia paling tinggi. Okay, in terms of the hydrogen bond sama je, tapi dia sebabkan dia ada van der Waals force. Van der Waals force dalam ethanol ni lebih kuat berbanding van der Waals force dalam methanol. Okay, sebab dia punya ni, nampak ni. Okay, dia punya area ni dia punya surface area, contact area antara CH2 dengan molekul CH2 yang lain tu lagi kuat dia pegang compared to methanol. So sebab tu boiling point dia lebih tinggi. Okay, itu adalah boiling point. Kita tengok dia punya intermolecular forces. Dan kita dah ada idea boiling point tu tinggi disebabkan strong intermolecular forces, perlu lebih banyak tenaga. Sekarang kita nak kaitkan dengan vapor pressure. Okay, apa yang terjadi semasa vapor pressure ni? Macam mana vapor terhasil? First, dia buat apa? Energy is absorbed. Okay, vapor daripada mana? Liquid to vapor, right? Okay, so bila liquid to vapor, that means this liquid need to overcome the intermolecular forces, right? Okay, energy release, absorb, right? Energy absorb to overcome the intermolecular forces. So, bila dia boleh overcome, dia akan jadi vapor. Okay, now, if strong intermolecular forces, okay, is it easy or difficult to overcome the intermolecular forces? Kalau strong intermolecular forces, energy susah ke senang nak overcome? Susah. Okay, so required more energy, right? Okay, bila perlukan lebih banyak tenaga, banyak tak vapor yang terhasil? Tak banyak vapor kan? Bila tak banyak vapor, banyak tak pelanggaran? Tak banyak pelanggaran. Jadi vapor pressure tinggi ke rendah? Rendah. Okay, so we can conclude here. If the intermolecular forces strong, we need more energy and cause the boiling point to be higher. So boiling point will be higher. And if strong intermolecular forces, masih strong intermolecular forces, very difficult to overcome the intermolecular forces. So less vapor produced, right? Okay, dia nak form ni, gas yang terbentuk ni sedikit. Ya, nanti dia tak nampak. Okay, nampak ke tak nampak? Tak nampak. Okay, ada tak nampak dia orang? Boleh dah? Strong intermolecular forces. Very little gas vapor produced and gas particle produced, and then less collision, right? Sebab star nak escape, vapor pun sedikit, molecule vapor tu sedikit, collision pun berkurang, so vapor pressure akan rendah. Okay, pressure dihasilkan bila pelanggaran molekul gas tu. So, we can conclude that strong intermolecular forces cause the boiling point to be higher but vapor pressure to be lower. Okay, saya tak nak you hafal, saya nak you faham proses dia. Okay, so in this case, ethanol and okay, tadi kita dah mention methanol dengan ethanol ada hydrogen bond. So they hold strongly. While ethanol weak van der Waals forces. Kalau ethanol weak van der Waals forces, perlu banyak tenaga ke sikit? Sikit tenaga kan? So banyak tak particles dia yang boleh escape jadi vapor? Banyak. Banyak gas ethanol. Banyak tak pelanggaran? Banyak pelanggaran akan menghasilkan pressure yang tinggi. So vapor pressure dia tinggi. It's because of the weak van der Waals forces. So ini ikutlah. Dah ke? Okay, soalan yang 23. Explain fixed shape of solid. Kenapa solid fixed shape? So particles are packed closely. Okay, so bila dia pack closely, number one is dia punya susunan, is packed closely. Bila dia susun sangat rapat, they form intermolecular forces. So lagi kuat dia punya intermolecular forces, and then boleh tak dia flow? Dia dah tak boleh flow dah. Okay, so the particle only vibrate and rotate at fixed position. Rigid arrangement making the solid has definite shape. Okay, because of their arrangement. Next. Okay, ni soalan yang sama macam condensation tadi. Menggunakan kinetic theory, explain the process. Okay, first tadi saya kata apa? Bagi phase changes. Lepas bagi phase changes, energy absorb ke energy release? Lepas tu, kalau bila energy absorb, kinetic energy dia tinggi. So energy tu buat apa? Kalau energy release, kinetic energy dia rendah. So apa yang jadi dengan IMF dia? Okay, that is the basic idea. Okay, sekarang saya nak you sama-sama berfikir. Okay, saya tak nak you hafal jawapan. Okay, now let's form the idea together. From liquid to phase, okay, freezing. State the phase changes. It is from liquid to solid. Okay, then energy is released or absorbed. Liquid to solid. Form back the intermolecular forces kan. Energy is released. Sebab sejuk kan masuk dalam freezer kan. Okay, energy release. Bila energy release, molekul tu ada banyak tenaga ke sikit tenaga? Dia dah buang dah tenaga. So dia kinetic energy molekul akan rendah. So bila energy release, tenaga molekul ni rendah, dia boleh overcome intermolecular forces lagi tak? Tak boleh. So intermolecular forces form and they cannot move freely. So they freeze. Okay, settle. Okay, next. Melting. Now, give the phase changes daripada apa ke apa? From solid to liquid. Okay, tengok susunan dia. Imagine the arrangement of the particles. Daripada rapat-rapat, duduk jauh-jauh kan. So, energy is absorbed or released. Energy is absorbed. So, the kinetic energy of molecule is high or low? High. So energy is used to overcome the intermolecular forces. Now dia dah tak duduk rapat, dia dah duduk jauh sebab energy dah overcome intermolecular forces. Okay, now can you get the idea? Okay, sublimation, it's from solid to vapor. Energy absorb or release? Nak pergi daripada duduk rapat-rapat, pergi duduk jauh-jauh. Daripada ada intermolecular forces, now no longer intermolecular forces. Energy is absorb energy, right? Okay. Because energy is absorbed, particle have high kinetic energy and used to overcome the intermolecular forces. So daripada duduk rapat, IMF overcome because high kinetic energy. So dia dah duduk jauh-jauh. Next is deposition. Terbalik kepada sublimation. It's from vapor to solid. So energy is absorbed or released. Energy release, molekul mempunyai kinetic energy yang rendah dan tidak lagi dapat overcome intermolecular forces. So the intermolecular forces form back between the particles. So they will, dah ada intermolecular forces tu, dia susun rapat-rapat lah. Jadilah solid. Okay. Next. Differentiate between the crystalline solid and amorphous solid in terms of their particle arrangement. Kalau crystalline solid, ingat dia disusun secara teratur dan sistematik. Okay, regular arrangement ataupun orderly. Contohnya NaCl. So between NaCl, Na and then Cl, sodium, Cl macam tu. Tapi kalau glass ni kalau kita pecahkan, bentuk dia tak teratur. And then susunan atom dia, contohlah dia atom dalam gelas ni, kaca ni adalah silicon oxide. So dia susun silicon oxide, silicon oxide saya tak tersusun. Dia tak ada regular arrangement like garam. Okay. So itu dari L ke apa-apa garam. And then amorphous solid adalah glass. Paling obvious lah. Okay. Bagi contoh, kalau metal, whatever metal, ionic compound, whatever metal combine dengan non-metal. And then molecular covalent. Contohnya apa-apa je lah yang covalent. H2O, CO2, apa lagi yang covalent? CH4 covalent. Molekul yang covalent. Lagi apa lagi? Alcohol covalent. Tapi giant covalent, it is covalent tapi dia bentuk struktur yang besar. Giant covalent structure. Contohnya diamond, fullerenes. Okay, Fullerene tu kalau you baca reference books, dia macam buku pula. Dia macam bola sepak tu. Carbon dia tu lama-lama dia membentuk satu sphere. That is giant covalent structure, either diamond or fullerenes. Dalam buku banyak lagi contoh. Okay, now kita nak explain, give comparison between the solid and liquid in terms of shape. Okay, so kalau shape solid macam mana? Fixed shape kan? Okay, and then kalau liquid ikut bentuk bekas. Surface tension dia tak ada surface tension. Liquid high surface tension. Viscosity, no viscosity. Dia tak boleh flow sebab dia fix. Kalau liquid, dia ada low viscosity, high viscosity, moderate viscosity, terpulang. Okay, so viscosity liquid ni pelbagai lah ikut jenis liquid. Macam air, dia boleh flow kan, low viscosity lah. Dia senang nak flow, so low viscosity. Contohnya kalau macam minyak petrol tu kan, dia pekat lagi kan, so high viscosity. Okay, so viscosity dia ada kaitan dengan intermolecular forces. And then compressibility. Solid cannot be compressed. Liquid can be compressed but less compressible compared to gas. Okay, now last kali. Dia kata soalan ni, kita tengok CO2 and diamond covalent. Dalam CO2 ada covalent. Ingat tak covalent? Is sharing electron. Ingat lagi? Chapter 4. Ni belakang ni ingat tak? You nama apa? Faiz. Covalent tu apa? Bawa elastik. Kau lah tak bawa sumpit. Sumpit dia dari sini. Apa dia Faiz? Tengok. Covalent bond is through sharing electron. Other than covalent, apa dia? Is electrostatic forces, right? Positive and negative, which is, we call it as ionic bond. It's between non-metal and metal. Kalau covalent is sharing electron. Antara siapa? Non-metal dan juga non-metal. Faiz, revise balik chapter 4. Esok saya tanya lagi. Memang saya suka attack orang. Okay, mana dah? Haris dekat rumah dia kata, oh selamat aku tak datang. Jagalah kalau kau datang. Okay, mana dah ni? Okay, so CO2 dengan diamond dia covalent. Tapi CO2 is softer compared to the diamond. Diamond ni paling keras kan. Dia guna untuk potong solid yang lain. So kenapakah CO2 is simple covalent molecule? Kalau diamond is giant covalent structure. So macam mana bentuk diamond? Carbon connected to another 4 carbon tetrahedral. So tetrahedral tu connect lagi dengan tetrahedral yang lain sampai jadi struktur yang sangat besar. So dia sangat kuat. Tapi kalau CO2, carbon, double bond O, double bond O. Itu je covalent bond dia. So habis. So satu simple covalent molecule, satu lagi giant covalent molecule. Okay. Habis. Beda Hakim. Okay, boleh stop recording. Dia nak tanya soalan. Stop recording.